Hello and welcome to Basin Academy. This is your safety instructor, Jonathan Greiner. Today we're going to be covering hand and power tools, personal protective equipment PPE, and machine guarding. These presentation topics go hand in hand, pardon the pun, but they're really designed to help you do a few things all together. One of those is making sure you're selecting the right tool for the job, you're wearing the right PPE, you're assessing the hazards to remove anything that would potentially cause injury, and that you're preventing all moving parts from making contact with you and your person. Now, this presentation is a little bit unique because I'm also going to link a podcast below in this video, in this presentation. It goes through all of these topics, but it does it more of in a conversational format. So between me and two other hosts, and we go through the presentation. So if you want to go through the standard presentation, great, excellent. The information will help you answer all the quiz questions properly. But if you want to hear more of a conversational model, you can click that link. It'll take you through the presentation, in more of an audible format, and you'll be able to, also learn enough to be able to pass the quiz and retain all the information. So with that, let's get this safety started. So we're going to jump right into hand and power tool safety. Obviously, hand and power tools are something we use every day for our normal life. Now, some of those things may be small, such as a screwdriver or a drill. Some of them would be maybe a little bit more dangerous and complicated, such as a grinder or a saw, a skill saw, something like that. So whenever our hands are not enough to perform the task, we're going to use some sort of tool. Some of those tools make it work safer, and some of them can pose a hazard, and some can do both. So main issues with using hand tools and the hazards that they present are cuts, scrapes, pinches can happen. We're going to talk a lot about pinch points today, amputations, impalements, or smashing. So hand and power tool safety, kind of the cardinal rule is selecting the right tool for the job. So if you're going to go do a job and it'd be better to use a closed end wrench than, a crescent wrench. That'd be great if you have the right size. I mean, when I was a lease operator, I like to have a 3/8 inch wrench. It just seemed to be like the golden tool for everything I did. So I'd use one with like kind of a ratchet end on it. And I found that prevented me from having to use a crescent wrench most of the time. But really, whatever it is, just using the best possible tool that really makes your life easier. And that does, add cost and maybe even a little bit of time thinking through, hey, is there a better way to do this job? But that's a main thing in the rest of these points that I'm going to mention here. So not just the correct tool, but the correct size tool, not using tools where they're not designed to be used for that purpose, such as a hammer for a, rather using a wrench where a hammer would do, for example. Avoid slipping while using tools, making sure you maintain a firm grip, and then wearing the right PPE. If you can't eliminate the hazard, then, PPE is going to be required. So knives and razors are a big one, obviously, in our industry. A lot of recordables happen because, particularly of box cutters, the utility blades, utility knives. People just cut themselves with them all the time. I have responded to and dealt with more OSHA recordables with these than any other tool or really any other type of job. It's when someone grabs a utility knife, that's when the likelihood of injury increases significantly, and particularly because the blades don't stay sharp for very long, and so you're ended up having to use a lot of force with them, and that's when the slipping typically happens and people get cut. So try not to cut towards yourself or other people, regardless of what sharp type of implement that you're using, making sure you have a firm grip. Again, right knife for the job. There are times where a knife is the only tool. It is the right tool. But again, just identifying and doing your risk assessment and saying, hey, this is dangerous. And we've all cut ourselves. If you're like me, probably more times than you care to admit, particularly if you're a safety guy. And pocket knives are kind of a no-no for this reason. Again, just the sharpness of them. And a lot of times their makeup, the way that they're manufactured is not for industrial purposes. So hammers, I already mentioned, making sure that you're not using the wrong thing as a hammer, but then when you choose a hammer, making sure you have the right hammer. So your fist is not a hammer. Making sure you hold the handle correctly, typically lower to the bottom is going to give you more strength with the hammer, and then using the right type of hammer in different scenarios. So in the podcast that I mentioned earlier, we talk about the Landman episode where, they're using I think it's just a sledge, to loosen up a hammer union on a flow line, and I believe it was on the tubing line where they were, for some reason, loosening a hammer union without bleeding it off. I don't know why they do that. And it came apart and explosion happened, and they were not using a brass hammer. I love it and I hate it. It's over dramatized, but it was a good, way for me to explain to my wife kind of like some of the hazards that we have out in the field, and that being one of them, just, using a sparking tool rather than one that's designed to prevent sparking, such as a brass hammer. And then also, if you are using a hammer, making sure to keep your body out of the swing radius is extremely important. So pliers and wrenches, another very common tool in our industry. I like to have a bunch of different options, even at my house, and just using the right one. And, sometimes you think one is going to work better than the other, and it doesn't. I mentioned closed end wrenches. Those are, really helpful. Crescent wrenches are pretty common. Pipe wrenches, we've all got those in our pickups. Just making sure you have the right size. If you're using a pipe wrench, for example, and it's to its full possible, width when you open up the teeth and on something, maybe that's not the right size. I like to, have one that's sized no more than 3/4 of the width of its bar, just to make sure that it's properly sized for that, pipe or whatever it is that I'm loosening up. Power tools, we get a little bit more into this in the next presentation, but just really briefly, they are power tools. They do spark. There are intrinsically safe ones. It would be very surprising to me if anybody had a true intrinsically safe power tool. There are brushless motors, which obviously provides additional safety precautions because they're not sparking inside, but that is not intrinsically safe. Some other, new additions to power tools over the last few decades is essentially the insulation method of the hand casing of the tool. When I was growing up, working on my grandpa's farm, we had a drill called Sparky. You plug that puppy in, man, you'd be drilling stuff in, and you'd want to get done with that job as quick as possible because you were constantly getting shocked because the wiring inside made direct contact with the housing where you held it, and you just got shocked a lot. That's Sparky. That's what it did. And so obviously that's an update. I think he still has that, and it's now passed down to my uncle. And it's in his Quonset, but that's those tools. They last forever though, so you got to give them props for that. Some other power tool concerns. Obviously, we kind of generally know the purpose of these tools, but some of the hazards that exist are the rotating parts in them. We want to make sure that just like the hand tools, that the right type of power tool is used in its purpose. I mean, if you're mechanically inclined, which most people that are listening to this probably are, that really the main function of anything power is the rotation. Fast rotation equals rotations per minute equals the ability to power something, and just making sure we have the right sized tool or drill or bit or saw is important when we're going to use power tools. So saws, these are not something we're using a ton on the production side of oil and gas, but there are times where they're needed. But even at home, just making sure that first of all, your blades are sharp. Secondly, that no one around you could get hurt. You're wearing the right PPE. Dust collection is kind of I'd say a soft hazard where you don't want to be breathing in the dusts. And then that your hands are always not in the way of the blade in any way. And there's a ton of safeguards they have nowadays for these. You probably have seen the YouTube video where, and I'm actually going to link that in here. I'm going to put that in where there's a safety feature where if the blade touches a soft, particularly a water-based deal, they even use a hot dog in the video, I think, it instantly shuts itself down and then drops the blade underneath the table saw plane. And there's a lot of safety, metrics and safety things that they have out there for different types of saws these days. Big one, and we're going to end the day's topic with this, is guarding. So it's tempting to remove guards on these things because they can feel like they get in the way. And what that means is you do not have a big enough saw. So I have a table saw. It's got a 12-inch blade maximum size on it. And the guard really only allows me, I think it's maybe 3 or 4 inches without having to lift the guard in there. And obviously, a portion of that is below. So really I'm getting maybe max 4 inches. Sometimes I got, a 6x6 that I need to cut, and then I got to bring it over to my neighbor, Dwayne, and Dwayne's got to help me. And I hate it, but I'm not, maybe I'm just too cheap to go buy the bigger saw, but for most jobs that's going to work. But that's what you got to keep in mind is, hey, what is the tool that I'm using? What is it designed for, and not overwhelming it or removing guards so it can, kind of, jimmy the job that you need to get done. Grinders are another serious thing that we do use a lot in the oil and gas industry, not particularly, again, on production maintenance, but definitely in any sort of metal work or maintenance work. And the major hazards are that whatever grinding, whether it's a wheel or a Dremel type tool, just making sure that it's secure into the tool, that it's in good condition, and that you're wearing face protection. In this picture that you see here of the individual with the wheel in his face, that's a North Dakota photo, and the guy was actually wearing a face shield, and the type of grinder wheel, it broke apart. It was a brand new one out of the box and broke apart and went up and underneath his face shield. So even wearing the right proper equipment, this is dangerous equipment, period. No way around it. You got a lot of RPMs, you get loud noises, and if you're not wearing holding the grinder firmly, or even if you do a ring test, these things can still break apart. So making sure guards are in place for sure. And then again, making sure you do your ring test on your wheels. So tool safe use, general precautions, knowing what PPE is required for the tools, be on the lookout for others around you, making sure you're doing a risk analysis or a JSA, even if it's mental. If you're not doing JSAs on a daily basis, doing a checklist of like, what's the worst thing that can happen while doing this job, just kind of keeping that in mind. All right, with that, we're going to move into personal protective equipment, really what employees need to know to be safe in the field. This is an OSHA standard, that's, one of the first ones that really took the industry by storm, if you will. There's been years and still are some companies that don't necessarily take this overly seriously. And there are some limitations to PPE. So in part, they're not wrong. But at the end of the day, we just really want to make sure that we're doing everything we can to protect ourselves. And, at the end of the day, the last line of defense, that it's in place. So our objectives are talked about first of all, the PPE assessment process. So what PPE is needed for the type of job, why you use different types of PPE, and know how to properly care for and wear your PPE. So assessing the hazards is kind of the big first step in PPE selection. Knowing why you need to wear the PPE and where the PPE is going to protect you. But again, last line of defense, very bottom of the hierarchy of controls here. You can see, and we'll kind of break this down as we go through, but elimination is number 1, substitution is number 2, then engineering, awareness, and administrative. And then very, very bottom, last line of defense is PPE. So making sure we're evaluating the jobs, determine if the hazards are present, what hazards are present, and what the worst case scenario is. Check for all hazards to any part of the body, and determining the appropriate PPE is kind of the PPE hazard assessment, golden rules. I'm not going to say it again, but there it is. PPE is the last line of, I said I wasn't going to say it again, so I'm not going to say defense. All right. Face and eye assessment, doing that, what are there materials? Are there dusts? Are there sparks that can get into our eyes? Is there molten metal, hazardous liquids, acidic or caustic liquids, even gases and vapors or light radiation are things, for our face and our eyes we want to use and select the proper PPE for. Again, we talked about face shields already. Goggles may be a better solution in some instances, such as our hydrovac operator here, rather than just using safety glasses because, they don't protect you from everything. Respiratory protection, particularly in our world, there are sites that have H2S. We want to make sure that we have the right, respiratory protection equipment in those cases to protect our lungs. We have vapors and fumes. I mentioned the soft hazards of dust or particulates. Those typically aren't as immediately dangerous as, H2S can be, but they can still create long-term problems. Lack of adequate oxygen is another huge issue. making sure we know the source of the, gas or vapor or dust or fumes. And so we can eliminate that again, number one, in the hazard assessment tool. Can we eliminate it so we don't have to use the respiratory protection is kind of the number one thing. Making sure we understand the job we're about to do and monitoring our exposure. Those are kind of the main parts and components of respiratory protection. Hearing hazard, what are we doing that's over 85 decibels? That's kind of the, the minimum threshold for hearing protection. Decibel meters, pretty easy. They're defined, they're cheap. You can find them on Amazon. You can use your phone for hearing hazard assessment. There's a lot of different things. And just like a lot of things, or safety metrics, time, distance, and shielding, the TDS. This is the same as norm. It's the same as fire. It's the same as a lot of things. With hearing, it's, the shorter the amount of time you're around loud noises, the further you are away from loud noises, and the barrier you have between yourself and loud noises are the main components of protecting yourself. And making sure that people that are working around loud noises consistently, typically over 8 hours a day, that their hearing is monitored. And then lastly, that it's done consistently. The head hazards, what can drop on you? Are you going to bump into something? Are there low-hanging obstructions? Are you walking through low areas where you could hit your head on things? I'll say it. I'll admit it. When you wear a hard hat, it's more likely that you're going to run into stuff. It's true, particularly if you're working in tight spaces. But again, you have the cap to protect you from it, cutting your head or hitting your head or knocking you unconscious. And then also lastly, just sharp objects where we might be walking that the hard hat could protect us. Feet, slips are a big one. Dropped objects onto the toes are a big one. Safety toes don't protect you from everything that could be dropped because there's still other parts of your foot that are unprotected. And they do have something called a metatarsal guard to protect you from that. But also being in electrically conductive areas without the right type of boots, slippery surfaces, as I mentioned, hazardous chemicals and materials, and then even cold weather. If you're working out in the cold, and we'll get into this with hands as well, just selecting the right type of boot to protect your feet. So I like to mention scoria at this point because a lot of the, incidents, not necessarily recordable incidents, but incidents that I've responded to have been regarding people rolling their ankles on scoria. Super common, happens all the time. And the question is, what can we do to prevent that from happening? And mostly it's just assessing the hazard, saying, hey, I'm going to look down before I step down or check my walk path, make sure I'm not going to walk into anything. Particularly if you're carrying stuff, that's another area where, scoria can be an issue. It's like if you were walking normal, you'd be fine. But once you start carrying something and walking a little bit different in order to carry something heavy, that's where scoria can really become a bear and create a hazard. Ice snow, compacted snow, not necessarily every season do we have to worry about this. Obviously, when it's warm, we don't. But, that's another hazard we have to think about when we're selecting our footwear. And we'll talk a little bit about that in the next slide. There's cleats for this. We need to increase friction when friction of the ground is reduced. So I'm a big fan myself of the midsole cleats. They fit all types of sizes of boots. They're easy to, flip up if you're going to walk in an area where a cleat would create a hazard, such as metal stairs. And they just seem to last longer than the chain or the PVC grip type. Hand hazards assessment, I said we'd talk about this. Main concern, long-term concern, would be chemicals on our hands. A lot of guys I've worked with in the field that are older than myself, and there's becoming less and less of those guys, not because they're passing away, they're just retiring, and I'm getting along in my career more, but man, their hands are rough, bro. And I've got, some scars myself, but not wearing stuff that's protecting your hands will create, some kind of rough hands, and yes, that's a badge of honor to a lot of us, but not because of chemicals, make calluses fine, no problem, maybe a couple scars, but chemical stuff on your hands it's just not attractive, but more seriously, severe cuts or lacerations can happen. Make sure you have cut resistant gloves, again, when you're working around sharp objects. Abrasions, punctures, chemical burns, thermal burns, and lastly, cold temperatures, making sure we have an insulated glove as well. And, particularly for us guys that work outside when it's cold, it's tough because you're heavily insulated gloves typically aren't going to be your best crush or cut resistant gloves or impact resistant gloves. So, it is a trade-off, and, selecting the right one, or gloves plural, depending on what you're doing, that can be a little bit of a trick. For clothing, I've got a picture here of chem suits. That's not typically what we're going to be wearing. We're usually going to be wearing FR. We know that it's just a part of the industry requirement, and obviously protects us from flash fires. But definitely hazardous chemicals are out there, hot or cold, materials, objects, or weather, heavy, sharp, or rough materials, and moving machinery. And the clothing assessment, the reason I put the moving machinery in there, kind of going back to power tools, or really anything that has moving parts. We'll talk about more about this at the end of the presentation, or the last topic, just making sure that it's not loose enough to get pulled into those, or if it is loose enough, that we find a way to bind it or tie it back so it doesn't get pulled into things. Selecting eye and face protection, also extremely important. Prescription eyewear, shaded filter lenses, face shields. I got pictures of all those here, and just your general safety glasses. These all need to be impact resistant, which is an ANSI Z87. What they do is they standardize what they need to protect from. Just so you know, impact resistant does not mean you can take something being lifted by a crane to the face, for example. This is for small objects, essentially preventing that small and sharp objects coming at high speeds will not go through the lens. But again, larger items, heavy items, they're really going to provide moderate protection. So again, making sure you're not in the line of fire of those things is kind of step one. And then lastly, this is going to protect from smaller items and, higher, smaller speed items coming in and making contact with your eyes. So the wear and care, eye protection, particularly the kind of throwaway type safety glasses we have, they get scratched easily. They're softer lenses, so you gotta get rid of them if you can't see through them well. And if you have a favorite pair that gets scratched up, it's just part of the game. But putting them away when you're not using them. Don't let them roll around in the floorboards. Make sure they're clean. Wear them before exposure, and then again dispose of them if they're damaged or scratched. Respiratory protection really depends on the type of hazard that's in the atmosphere. Obviously, for H2S in the IDLH range, we need to wear full face piece SCBA with airline, whether it's the 30-minute pack or an air cylinder with a hose and a manifold that's coming to us. For dust and fumes, you have different types of cartridges, and just lining up, and the cartridge will tell you what it's designed for. If it's designed for ammonia or diesel or vapors or things like that, it's going to tell you. And then there's a color code for that as well. We go a lot more in depth into that in the respiratory protection training, but just a little blurb there on that. And then lastly, filtering half mask, which is kind of the baby version of respiratory protection. It provides very little protection, but in some cases, it works just fine. Already talked about the air supplied and the SCBA. If you're in IDLH atmospheres, these are 100% required. So respiratory protection care, keeping them clean, putting them away. Again, making sure they're not bouncing around on the floorboard or in the bed of your truck. Making sure they're in a case is pretty important. It's no different for the cartridges, same kind of thing. The cartridges, they do have an end of life, both an expiration date and, they get clogged. So just like any filter, once it starts to get, you're preventing from being able to breathe properly because it's clogged up, you got to get rid of it. Hearing protection, same kind of deal. They can become damaged pretty easily. So making sure you're storing them properly and, candidly making sure you select the right type is based on the sound that you're around. The different types of hearing protection have an NRR, is what it's called. It's a noise reduction rating, and you take that number, it might say 35, which is the number of decibels, and you split it in half. So that means that each ear would be protected from 17.5 decibels. So just keep that in mind. And then wear and care of head protection, making sure it fits properly. And this really goes for all PPE, making sure it fits properly. You inspect it before use. You keep it clean, and it's really only used to protect the head. I mean, I've seen some crazy stuff with hard hats. Well, crazy. You use them as a little step stool, these different things that they've been used for, I've seen. But yeah, just their only purpose is to protect your head. And candidly, the inside of the hard hat, the harness in the hard hat, that does have an expiration date of a year. So if you've been using a hard hat for more than a year, that harness is supposed to be changed out. Foot protection, we already kind of talked about some of the different scenarios, but just making sure you have the right type of foot protection for the job. You're working around a lot of chemicals. Obviously, we have chemical resistant boots for that with the hard-toed insole. Leather is going to be good most of the time. And then just making sure, again, they're comfortable. You can work in them all day without creating other foot issues. And that once the soles start to get beat up and tore through, and especially with chemical boots, that you change them out. Once you get a boot, it feels like once you get a pair of boots broken in, that's about the time you need to change them out. But yeah, that's what you need to do once the soles start to get, they start to lose their ability to hold friction and traction. Hand protection, I already kind of went through this pretty deeply. If you're working around sharp objects, cut resistance, great. If you're working around pinch points, impact resistance, great. But again, they have their limitations, and some of them even are really hard to use because they make you less nimble. And at times, and a lot of times in our work, flexibility, I was going to say nimbleness, I'm not sure that's a word, but let's call it a word. Nimbleness is important. Then, you're going to be at a disadvantage. So just making sure you have the right type of glove and you assess the risk properly. Hand protection, taking care of it. I mean, the most common thing is they're just going to get worn out. They do tear from time to time. That can happen. And if that does happen, then just make sure you get a new pair. And the other one is, absorbing chemicals, particularly around cotton or fabric type gloves. Fall protection, there's literally week-long courses about fall protection, but I'll try to sum it up in a very short slide here. Make sure it fits tightly, particularly around the legs. They can have no defects because they're designed in such a way that, and only when they're in perfect condition, essentially, are they designed to hold and withstand the impact of a fall. Tags must be legible on the fall protection, so usually they're protected by like a Velcro strap. Any connectors must move freely, no rust or anything on them like that. And then making sure that your D-ring, which is where you connect your lanyard or your tagline, if you're in a rescue situation, make sure that they're positioned properly so that you'll be, if you did fall or were being rescued, that you'd be ergonomically in good shape and not be bent over halfways, hanging in the air. And general work clothing, I talked about looseness of fit. It's not a great look or safety precaution. Jewelry, also kind of a no-no. I've got a rubber wedding ring for those days, or candidly, I keep it in my work backpack just in case I forget my regular ring, which happens from time to time. So, and I always got to wear a ring because you never know. You're in North Dakota, there's just so many women everywhere. You just got to make sure they know, you know what I mean? And really, flame retardant is kind of the most common thing that we got to be careful of. So kind of wrapping up our PPE section here, every job function may require PPE. We assess that. Most in our world, though, just to kind of be completely transparent, a lot of this assessment has been done prior. So our normal garb, hard hat, safety glasses, FR clothing, hard-toed boots, and then some type of glove, that's pretty much standard. But just because it's standard, sometimes that means, we feel like that's enough, and sometimes different PPE is going to be required depending on the type of job that you're doing. So keep that in mind. You want to consider every part of the body, including the lungs and the eardrums when you're selecting PPE, and just making sure you're taking care of it and getting rid of it when it's time. So getting into our last topic for today is machine guarding awareness. There are all types of guards. We're going to go through a lot of them, but there are a ton of types of guards. Really, the point of it is to make sure that people do not come into contact with the point of operation of machines. So we're going to talk about the importance of it, obviously, different types of mechanical hazards, causes of machine accidents that we see are common, the regulatory requirements surrounding machine guarding, methods of safeguarding machines, specific hazards, best practices, responsibilities and training, and then lastly, we're going to wrap it up and call her a day. So machine guarding is obviously important because fast rotating stuff and soft, flexible appendages do not mix. If If you've worked around ag, all of us have an ag story of a friend or a friend of a friend, or maybe even a family member, where there's been a fatality because they've been pulled in machines that were maybe guarded, or maybe the guard was removed, and it's just big equipment. So the bigger the equipment, the bigger the rotating part, the more potential hazard. So obviously injuries, amputation, fatalities, fractures, crushing, all these are potential hazards of working around machines. There is a high injury statistic for machine injury, so particularly around hands. That's the most common, but depending on, the size, even just getting a sleeve pulled in could prove fatal. And then lastly, just loss of working capability. Typically machine guarding injuries are career-ending injuries where, whatever happened prevents you from being able to work in the future. And, so they're pretty serious. We take them pretty serious. So key terms, we have point of operation. I already mentioned this. This is the area where the actual work occurs. If you're cutting, wherever the blade's hitting the material, that's the point of operation. Shaping, boring, wherever the implement is touching the thing. Or if it's a moving, machinery, that's our rotating parts, gears, pulley, flywheels, couplings, and then nip points are typically going to be your chains, sprockets, rotating cylinders. And if you've worked around workover rigs, all of these can be all of these, right? There's points where chains are used for operation. Not as much as back in the day, but it does happen. Tongs, anything like that where the machine is moving. We want to make sure that we're protected from being caught into that or things coming out of that in the area that we're working. Common accident causes: clearing jams improperly. It's pretty common. Failure to use lockout, tagout, unauthorized use by untrained people, or missing or loose guards. And clearing jams, I mentioned the ag situation. A lot of the stories I know is where, whether it's a combine or something it's got rotating parts, something gets stuck up in there, lawnmowers, and people reach in to remove the jam without turning the equipment off and releasing the stored energy. The rotation occurs, and that's where the injury or the fatality happens. So unsafe machines, if they're not working properly, intermittent, loose gears, seals that are gone bad, bearings that are going bad, things like that are pretty common reason for accidents as well. Removing guards, super common. That's why this is called machine guarding. And then incorrect usage and or unsafe actions are all kind of a big part of where machine injuries and accidents happen. So the OSHA standards really establish worker safety guidelines. So how do we protect the worker from machines? Obviously, machines are a big part of industry. So the primary goal of OSHA is to ensure employee safety from these hazards, mostly rotating parts, flying chips and materials, and sparks through adequate guarding methods. So that's pretty much the whole chapter. And if you want to, look it up, that subpart, it's about 30 pages long, maybe a little bit shorter than that. But yeah, it's a pretty dry read, but there's definitely a lot of good information in there. And that's most definitely, a lot of people say, oh, the OSHA standards, they're written in blood. And this is definitely one where that is 100% the case. So preventing contact, securing people from and protecting people from falling objects. This is really the requirements for any safeguards of equipment. And then no interference of the actual job, and allowing lubrication without removal. These are kind of the main important things of safeguards and equipment guarding. So I just want to reiterate that guards should not prevent you from being able to do the work, right? And if you've used a grinder before, you may laugh, but it's true. And typically if the guard is preventing us from doing the work, that probably means we don't have the right size tool or the right tool at all. So just keep that in mind. So classifications of safeguards: we have fixed, interlocking, adjustable, and self-adjusting guards. We have presence, sensing, pullback, and restraints. And we have location, distance, feeding, ejection methods, and then miscellaneous aids. And I'm going to give some examples, and we're going to go through them here one by one. So fixed guards, I already mentioned. This is something, just permanently there, right? Think of, a fence around a pumping unit would be an example of a fixed guard. And you might say, hey, well, you can remove that pretty easily or jump over it. That's true of all fixed guards. They're there, but there are ways to bypass them. Interlocked guards are a little bit different, and they even, to some extent, would be in the presence sensing. These two kind of work together, but these are adjustable shutoff mechanisms where a washing machine is an example where the door has to be closed for it to operate. The reason for that, or a dryer. So there's a little, switch in there, and once the door fully closes, then it can turn on. That's called an interlocking guard. And there's a lot of different equipment that uses this, and we'll talk more about those. But that's a main machine guarding type of mechanism. Adjustable guards, typically bandsaw cutting would be one. My grinder has one. I have a Milwaukee grinder, and you can adjust the guard on there so that depending on what angle you're cutting, you can still do the work and protect yourself. Self-adjusting guards, such as on a table saw that I mentioned earlier, they'll adjust as the material goes through and then drop down once the material is through. And then presence sensing devices, think of a riding lawnmower. Again, if presence or pressure, if you're sitting on the lawnmower, it'll run. Once you sit up from the lawnmower, it will shut off. Bypassing that can be really dangerous. I met a kid, one of my first safety classes I ever taught. He was probably in his early 20s at the time, and he, lifted up his pant leg to show his calf, and it was just, basically half of a calf. And, he told the story of how when he was a young kid, his dad had him using the riding lawnmower, and he disconnected I don't know exactly what he did, but he disconnected the pressure sensor on the seat. And the kid, he's 8 years old, he's riding, he sees something in his way, a rock or branch or something, gets up to remove it, forgets to put it in park, and it runs over the young man's leg. And he was lucky he didn't lose it, but, even at home, be thinking of this stuff. Machines do hurt and kill people. So other types of controls, pullback or restraint devices, think of like a treadmill, but there's other ones as well where if you move into the danger zone, you have something attached to you and it will shut off the equipment if that's pulled. Safety trip controls, same kind of thing, trip wires, cables, pressure sensitive bars, two-hand controls, operator safety during machine cycles. This is pretty common nowadays in heavy, even hand tools where, you have to be pushing two buttons for the machine to continue to work. And expanding on that, it'd be two hands being used, typically in presses and rollers and things like that. This is pretty common. And then location and distance safeguarding. Basically you have to be outside of a certain area for the equipment to work. Automatic feeders where you don't have to be in the work area at all. And then protective shields and awareness barriers, such as, again, a pumping unit. Fence would be an example of that. So fan blades, just so everyone's aware, anything below 7 feet, fans need to be guarded. Abrasive wheel machinery, specific space gap requirements. Again, make sure that you can't fit a body part into an area where an abrasive wheel is working. And then lastly, any sort of power transmission apparatus, guarding belts, pulley shafts. If we're using a pulley or a belt to run something, that is also protected so that you don't get pulled into it. So kind of getting close to wrapping this up here. Best practices overview, making sure that guards are in place, they're maintained, they're in good shape, they're not cracked or broken or chipped, no loose clothing, jewelry, or hair around machines, and then making sure that guard removal, if it ever happens, is done in a safe way when the equipment is turned off, and that we're following safety procedures around the machine guarding. So the safety responsibilities, according to OSHA, for machine guarding, management ensures that machinery is guarded, that the resource allocation is there for paying for those guards, and that, it's not like, hey, we lost a guard, well, we can't afford it, but just keep working. That'd be a management responsibility. Supervisors are there to make sure that their employees are using the guards properly, that the guards are installed, and that they're not being bypassed. And then employees need to use those properly as well, report any issues, and then shut down unsafe equipment. For whatever reason, it's not working properly or there's a safety concern, you need to turn it off and then tag it, do not operate. And then training, some machinery, training is pretty simple. Let's take a drill, for example. You don't need to take a 3-day course on how to use an impact drill, but some sort of verification that individual does know how to safely use the drill isn't a bad idea, particularly in today's climate. Guard use, removal, and maintenance needs to be trained, and people need to understand, particularly if they're considered qualified in that equipment or perform maintenance on that equipment. And then if there's an issue, it just gets reported promptly. And so kind of wrapping it up, like I said, we're getting close and we're there now. Make sure that equipment safeguards are always in place, and any machine part that moves is guarded. Basically, if it moves, it's needs to be protected from somebody touching it. Do not operate unguarded machinery. Don't remove guards, and if a guard is removed, don't use it. Report safeguarding problems if there is a guard issue, and ensure guards are correctly adjusted and functional. Again, a big part of all of this is that we are able to perform work and that the tools that we're using can perform the work safely. Most times, again, if we can't, it's probably because we're not using the right size tool. Well, with that, we're going to wrap up today's presentation. Thank you so much for paying attention. And with that, let's keep this safety going.